Hey AP Chem guys, I didn't really find a video that I liked, so I made this one. We'll see how it turns out. Coulomb's law, briefly stated, is what you can see here, that the force is equal to this K value times Q1 times Q2 over D squared. So the F is the force on the charges, and K is a constant, and it's needed to kind of scale the equation depending on the units that you use. Q is the charge on object 1, Q2 is the charge on object 2, and then D, and sometimes you'll see this as R in the equations, is the distance between them. And that's Coulomb's law, and that's simple enough. But what we'll be more interested in talking about is not so much the force, but rather the energy. And you can see this equation here that's very similar to Coulomb's law. In fact, it looks almost identical. The F has been replaced by an E, and the D squared is now a D. And that is the potential energy of the charges. Again, E stands for energy, and then everything else has the same meaning as before. So let's go and look at these charges down here. We have Q1, which is positive, Q2, which is negative, separated by a distance of D. So the energy of this two-charge system is simply Q1 times Q2 divided by the distance between them. If you move them closer together, the energy of the system will go down. And that's because Q1 being positive and Q2 being negative, if you multiply them together, you'll get a negative number. And so as they move closer together, this D gets smaller, and that will cause the energy to go down because it was negative, and then it's being divided by a smaller and smaller number. If you move them apart from each other, then the energy will go up. If you flip this negative into a positive, now both Q1 and Q2 are positive, and so now the sign of E just flipped from negative to positive, and that will make the energy of the system go up. So that's it. That's just the essence of it. The electrical energy is equal to the charge on object 1 times the charge on object 2 divided by the distance between them. So more distance, if the charges are opposite, more distance will mean less energy. And less distance, I hope I said that right. If the charges are opposite, the closer you bring them together, the less energy you'll have, the more negative energy in the system. And that's really the key point. If the charges match each other, both negative or both positive, then you minimize the energy by moving them far away from each other. Again, if you can also, if Q2 grows in size, then that will also make this E value change, and so it will become more negative. And I feel like I've said all I have to say for now.